which is for EMODnet bathymetry and the high resolution seabed mapping to increase the resolution of the product for the European seas by Schaap.
Coming? Yes. Yeah, almost there. But I'm now looking for the button. Now it's on top, eh? Yeah. Yes. You got him? Okay. Yeah, I would like to present another part of the EMODnet family, which is EMODnet bathymetry. And in fact, it's making a high-resolution digital terrain model for all the European seas. And I do this, let's say, on behalf also of my colleagues in the consortium, especially Thierry Schmitt. He is the coordinator, I'm the technical coordinator. But Thierry is right now in Canada also presenting the same presentation. But we could not be at two places at the same time in that way. Our overall aims is what we want to do and want to do in EMODnet bathymetry is to bring together, let's say, all the bathymetric survey data and also composite DTMs. And I have to explain it a little bit to you, because composite DTMs is that we have several providers. They already use their surveys, let's say, to produce a DTM for their own area. And that's what we call a composite DTM. And that happens especially if you have, let's say, national hydrographic services. They do that. So what we do, we bring together the survey data, we bring together composite DTMs, and also in the last 10 years, let's say, we also bring together satellite-derived bathymetry, because we still have a lot of areas, especially coastal, coastal transition areas, where we do not have a lot of detailed surveys. And then we are using the Sentinel data to derive by a 10 by 10 grid, let's say, also the bathymetry. And that works in a lot of the European waters because they are transparent enough, and it can work up to, say, 15-meter depth. And also we use LiDAR data because there is some LiDAR, let's say, on the coastal zone, which then takes a... And what we want to do is let's say, to produce the best digital terrain model for Europe. And over time, we started with, let's say, a higher resolution, but over time we are now in 150 meter by 150 meter, using, let's say, all the available data sets. But in addition, we work together with JEPCO, let's say the global product, because we do a so-called infilling where we don't have survey data. So then we make use of the back, let's say, back side of the JEPCO. And that's more based on altimetry at that time. While in the other way around, let's say the EMODnet DTM is being used by JEPCO, let's say, to improve the JEPCO for the European seas. And that's the way also in the Seabed 2030 we have a very nice synergy, I would say, on the global scale. And we learn from each other and we try to get a better result at both ends. And then, of course, we make this DTM available for a wide audience. And you know, bathymetry is a base layer for many people, for many applications at sea, also in economy-wise. And that means that we have a lot of interest, and therefore it's presented through the central portal nowadays, let's say by the map viewer, and you can also download tiles. But at the same time, there are a lot of OGC services which are widely used, I would say very widely used worldwide, for people to have in fact, a base layer in their applications. And they project then their other data on top of that. And that's very nice. And also during these sessions, you see a lot of times we see that product, which we call the global base layer, and that's being used by many of the applications. Another thing that we want to do in the project is that we develop so-called digital coastlines using all the available satellite information, and then mix it together, let's say, with the digital terrain, and also with a digital tidal model, to be able to have the coastline at 3 different reference levels, like lowest astronomical tide, mean sea level, and mean high water. And then, of course, look at differences in time. Now what we do for this, there's a lot of cooperation with EMODnet, because the CDI service that we presented yesterday and also has been named a couple of times, we use that as the backend to describe all the survey data that we get together. And right now we have more than 65 data providers that over time of the project, since we started in 2008, have come forward. And they bring every time new survey data, which we describe then with the CDI. We also have a sextant catalog, and we use that to describe the final products, but we also use that to describe these composite DTMs, because those are in fact semi-products, and we describe them, you know, or in the same, I would say the same common model, ISO 19115. And then we use a lot of controlled vocabularies, of course, which are of course, the whole CDI and Sextant, they are supported by these controlled vocabularies, and that makes it possible to make a very harmonized metadata. And it also makes it possible then for the products that we make to refer always to acknowledge, let's say, the data providers and the details of their data. And that's the important thing. So there's also always a track and trace between the product and the data. And that's quite nice. Let's go further. So we have this mechanism. Let's say you have these two sources, the survey data and the composite DTMs, and then together with the process, we have the DTM itself. This is an overview of the CDI server. So right now we have about 40,000 data sets in there. We have also about 300 composite DTMs. And this is all the time evolving, because we have the project goes on all the time. But we have every 2 years we do a new product release. And that's, let's say, the way to show the new element. Then we have here the flow. So you see on the top, you see the data input. Then we have, let's say, a common tool for the processing, and we use the Globe software. That's the software being maintained by Verlaan, and that over time also became an open software, so everybody can use that. But it's not static. We are all the time maintaining, because by using it, let's say, and we work with regional coordinators. So we have divided, let's say, Europe in different regions, and we have a coordinator per region, which has let's say, a network of providers. And then they get a new harvest of the latest data, and then they have to improve, let's say, the previous version, because that's how you work. And therefore we are also working on more and more visualization tools, and also having an online globe to be able to, say, to compare the previous version with the new version and look at the anomalies between them. And that makes it, because these files are too big, let's say, in the end to handle just on your PC. You need help by a larger computing. And then, let's say, in the end, then we publish together with the metadata, and that's now is going through the central portal. So these are some examples. So here we have the, let's say, the globe, and we have then the coverage of the European DTM in the central portal, and there are many layers there. Just like Antonio showed you, there are several layers with different aspects. We also are now doing the Caribbean, part of the Caribbean, and this is, in fact, based upon data that is, let's say, countries and regions which are related to European countries. So we have the Netherlands, we have France, we have the UK, others, let's say, they have data sets, and they also have a responsibility for mapping and bathymetry in those areas. And we use that, again, of course, together with JEPCO. Then we have here this layer menu, so you see the different, we have a couple of legends, different ways to show the bathymetry. Then we also have this source reference layer, and that's in fact, let's say, the track and trace. So here you see the mosaic, which is behind every grid cell. And in this way you can also do selections, but also you can click on something and then you get the metadata of that specific data set that was used to create the DTM in that grid cell. And that's widely appropriate, and I think also widely, let's say, appreciated by the data providers, because it means in practice that we get more and more data providers wanting to join the project because they want to be on that map, they want to be in that mosaic. And it is a little bit comparable to the World Ocean Database. I think they'll say the same mechanism, that people love the product and they want to be associated with the product, and for that they want to release the data and make it part of that let's call it beautiful product. And that's, so here's some examples of the metadata. Then we have also the survey tracks, so they come from the CDI. So in this case you can then find the, let's say, the base data, the survey data. And also we have a simple download server, so we have tiles, and those tiles, each tile is about 1 gigabyte. So you can easily, in 8 different formats, you can download the data sets and use them in your own system, your own GIS. Or you make use of the machine services, the OGC, we have WMS, WFS, WCS, and we have WMTS, tile server. And also there is a CSW for the product information. And this way, let's say, a lot of people do that. And we have, on average, we have about 10,000 downloads, let's say, every quarter. And it's for a wide range of users. And also in industry, it's very interesting if you go to, let's say you talk to Fugro or some big companies in the offshore domain. They all use this product as their back layer. And they use it in a quite interesting way, especially with Fugro. In the beginning they said a little bit, hey, you're competing with us. They said, no, we are not competing. We're making a generic product, which is 115 meter by 115. So it's nice for, let's say, pre-engineering, but the moment that you really want to do a pipeline or whatever, you need higher resolution. And they use now this product to show you what we know, but also what we don't know, and what they can supply you. And that's their business model, and that works very nicely. And also they are now also helping us, let's say, with same as with Seabed 2030. Also the industry is coming more and more saying, how can we use our data also in this model? Because we want to be associate, but also we are big users, so why not improve the product with our data to make it better? And that's quite a learning curve. We also have some high resolution areas where we go to even sometimes 1 to 10 meter. And that's depends a little bit on the local data policy, let's say. So we see several areas where we have very high resolution, and about 300 now, and that most of them, they are interesting areas, let's say, like seamounts, that could be ravines, that could be very interesting coastlines, and that's really making progress. But it's difficult to go to a higher resolution as an overall, because if you go to 50 meter by 50 meter, that means you need much more data that qualifies to that. So it must be high resolution data. And we have a lot of multi-beam, but also still single beam a lot. And another thing is, of course, that in several countries, let's say, there is a limit a little bit what they want to make public, simply for safety and security. And that's nowadays is a reality, of course, in our world, that you cannot share all the data, because otherwise it might be used in the wrong way. And that's also with bathymetry. Now, this is an example of high resolution. That's in the forecoast of the Netherlands, and that in fact this was an area where they used a new dredging machine, and they want to tire it out, and they made a very nice, let's say, trenches there. And that's then the level of high resolution that you can get when you zoom in certain areas. We also have a world base layer, and that is a common product using JEPCO and the let's say the EMODnet DTM, and it has been made in the same resolution, so 115 meter by 115. But of course, parts of that are then interpolated, because you cannot go from 1,000 meter to 150 meter. You still have, but you can work with this. And this base layer is a very nice product that is also being used a lot worldwide. And there's also a land DTM, I call it a land model, and that's done by satellite composite. And these are together, and there's also widely used, let's say, only as a OGC surface. So now finally is just one slide more, I think, is that we have an international collaboration also with IHO and JEPCO, I already mentioned, and there's also IHO is maintaining a website, in fact a reference website where you can see all the survey data worldwide. And this is also again done by the OGC services, so they simply pick up our OGC threads, and they put them in, and if you click, you can find the CDI metadata of different datasets that you are interested in. And that is also all a collaboration with Seabed 2030, I already explained. And then conclusions, we are a leading project in Europe, especially for bathymetry. We are well recognized. It means that all the national hydrographic services more or less are now members of our group. We also have a lot of, let's say, research institutes, and they are complementing each other, because the hydrographic offices, they have a certain task, let's say for the fairways and the maritime seaways, while the scientists are more interested in the phenomena, let's say, the outliers and the special bathymetry, and they come together. In the beginning, it was a little bit difficult, because we had different social groups, they had different ways of operating, but we managed to put them all under the same frame, I would say. And now we have a lot of innovation, also looking at AI and in-painting and super resolution, let's say some new technologies that become available. And you see that both groups are very triggered, in fact, to work together on the same subject. And that's something that also happened in this way. EMODnet bathymetry became a team effort. In the beginning it was more a project, but later it became a team effort, and now everybody trusts each other. You know, when you have a base of trust, you get much better results, and that's they call it co-creation, co-design, but that's how it works. We have many users, so like I said already before, we have 40,000 downloads on the year, and we have also millions of OTC hits, and finally, that's the way we go forward, and we hope to do this for a long time still to come, to be able to every 2 years churn out a new resolution and a new release. Thank you. Any questions?
Thank you for the interesting presentation. How do you handle the huge amount of bathymetry data that you receive? how do you receive it practically?
Mhm.
I mean,
Yeah.
I think it's terabytes we're talking about.
Yeah, as a total. But what happens is that we have we have this metadata system. So we describe all the data in the system with specifics. Then we have the data itself, and the data itself can be ASRI, it can be XYZ, it can be several formats coming from the multi-beam and the single beam. And these data sets, they all say there's the software called Globe, which is a local software that is provided to all the regional coordinators, and they use that software to process those individual entries. And then they have, let's say, a common grid, already the EMODnet grid and the EMODnet specifics, because they link it also to the metadata. And then they, in fact, bring it together in this, we call it then their regional DTM, so they make a compilation, like a jigsaw puzzle, and that's all done with Globe. But what happened was that, in fact, they had to chop it up in pieces, let's say chunks, to be able to handle it in a good performance. And for that reason, we are more and more developing, together with Ifremer especially, let's say they are leading this, to make an online Globe, which is then served out by the cloud, and then the regional coordinators, they can work on the cloud. And this way, let's say, they can overcome the limitations of the, let's say, the processing, and they can look at the regional DTM in one go instead of having to chop it up in pieces. And that's over time, let's say, this process every time it innovates, especially based upon the feedback of, in this case, the regional coordinators, but also the data providers, because we also put more tasks, more and more to the data providers, that they already do pre-processing for us, and not just give us a raw product, but that they already do, let's say, the same Globe activity locally, and then provide that further. And that's the way to, let's say, to optimize your project. In the beginning it was small operation, but of course it becomes bigger and bigger, and then you have to change your way of operating. And that's why we're also now looking in artificial intelligence, because we still have a lot of gaps, especially in coastal areas. And at the same time, there are footprints. You can say footprints, training model, you could say, how certain foregrounds or forecoasts are situated. And if you use those, you can do a lot of in-painting. So if you have, let's say, 100 meter, try to make it 10 meter and still have a reliable outcome. And those technologies are more and more, of course, getting, we have seen a couple of presentations, but this is coming. And if I stand here 10 years from now, it will be completely different, you know what I mean?
Thank you very much.
So if there are no other questions,